Never underestimate the creativity of someone trying to commit fraud. Today on the show, we explore yet another flavor of ad tech fraud. This time, something called placement laundering. It's a sort of a digital bait and switch. And luckily, there might be some ways to detect this as a statistical anomaly. We get into all that and more coming up next.
My name is Jeff Kline, and the paper was written while I was a lead data scientist at ComScore Labs, which is a research and development organization in the ad tech business.
And could you give me a little sense of what your academic background is?
I have a PhD in math from the University of Wisconsin, and my focus was on convex optimization.
Convex optimization can work in just about any industry where there's such a problem. Is that what brought you to ad tech?
No, I landed in ad tech quite by accident. My first job after school was with the LIGO project, where I did
Oh, cool.
work developing their data replication functions. I was reached out to by a founder of a startup based in Madison who was involved in detecting ad fraud. This is a co-author on the paper, Paul Barford, who's a professor of computer sciences at the University of Wisconsin-Madison. And he contacted me and described the sort of problem that they were trying to solve. And it sounded very interesting and cool, and I didn't know anything about it. So I said, sure, let's try it out. We were a startup in Madison. We had a small presence in the Bay Area, and we were in business for about a year before we got acquired by ComScore, and that was in roughly 2014.
Well, when I hear the term ad fraud, having been in the industry and whatnot, I know what it means, but I've learned that from talking to civilians or whatever you want to call them, when a person who hasn't heard that before hears ad fraud, a lot of what they think of is a advertisement promoting a fraudulent product, which is a thing that does exist, but that's not exactly what we're talking about. What do you mean when you say ad fraud?
Well, that certainly would count as ad fraud, but ad fraud is an umbrella term that covers a lot of different things. And at its core is somebody taking actions to defraud somebody else in the ad space. And what placement laundering is about, and that's what our paper is about, is people claiming that they're going to display a digital ad on one site, which would take premium price, and they're actually paying out and displaying it on kind of a lower quality site. So that lying, that violation of trust is where the fraud is occurring. But there are lots of other types of ad fraud out there.
Can you tell me a little bit about how this collaboration got started?
Paul and I had been working together on this issue of attribution in ads for quite a while, and we realized it was a problem. And so we did a lot of the background work investigating different instances of laundering and misattribution. And it became clear that we should, to move this forward from just an observation and working with the analytics, try to get a solution in place. And at that point, we brought in the co-author, Aaron Kahn, and together the three of us worked on the methodology that we put into the paper.
So with placement laundering, I could see where something like, I don't know, Reddit, it might be a premium site, or maybe not. Some fancy news site like CNN might be a premium. I would expect to pay a certain cost per click or maybe cost per impression, depending on the model, because those are known brand names with a lot of traffic and things like that, versus, Kyle's Recipes website.com, which could also have ads and might be a reasonable source of traffic, but it's certainly not the same thing. So it seems like it's a very much a obvious fraud. This can't be done by accident? Is this a deliberate act?
It is a deliberate act. You don't end up with premium names in analytics data streams by accident. Somebody deliberately places those names in like the refer field or in some part of the telemetry that's used in the analytics post hoc analysis of campaigns. And in order to do that, you need to have both an understanding of the business side of like how is money actually being transacted here, but you also need deep technical skill to understand how do I insert these fields into the telemetry so that people are either fooled or don't take a second closer look.
And is that a technique? Yes, I agree. You need some engineering skills. You need to know the industry, but that's something a good engineer could do in a couple of months, maybe less. If I set out to engage in this, what would it really take to set up a fraudulent mechanism? Or do we know the mechanism?
We see the results of it. So I can't speak specifically. I've not undertaken deep dives into diagnosing malware attacks that also participate in this form of fraud, but it's
Mhm.
not required. You can also participate in fraud just organically by taking out accounts and then just understanding what fields do you have access to, what levers are you able to pull by like populating what is the display URL, that sort of information. The technical level is, I think, higher now than it used to be, but it's not particularly high. It's mostly a function of how determined are you and can you make a go of it. The one thing that we really learned through our experiences in the ad fraud world is that the people who engage in this is their day job.
Mm.
They make money doing it. They do it in a sustainable way. There are the examples where somebody gets ambitious and makes a lot of noise, and the people who do that are the ones who get caught. It's the ones who sort of stay under the radar and are clever
Uh-huh.
that are able to make a real go of it long term in a durable way. But they also need to evolve, and we saw a little bit of that when I was still engaged in that sort of analysis.
Well, I doubt if you have any access to their finances to give me a concrete answer for this, but do you have any rough estimate of, if it's somebody's day job, what kind of wage can they bring home committing these acts?
We had to infer this because we don't, the perspective of the data that we had was from the perspective of, well, we can get into that later, but
Mhm.
we didn't have detailed account information. But based on what we saw, which was market rates and the volume that we were able to see, we estimated between 200K impressions per day and 5 million impressions per day. And that would run over the course of 30 plus days sometimes. Sometimes it would run for a week. I don't suspect that all of that money was being flowed directly into like an individual's account, but it was sort of the order of magnitude of money that we saw attributed to this,
Enough to make a living, which is quite a bit.
certainly.
And then I know the techniques might be something like stuffing that HTTP refer header with the wrong information or something like that. How can you detect it if you don't know the source of it?
Detection is a challenge in this space. The main way that we were detecting these instances was on sanity checks. We needed to understand what we expected to see, and then we would undertake kind of a manual review on these types of features that we expected to see, and any kind of discrepancy we would then dig into. And discrepancies between what we expect to see and what we actually see are not necessarily fraud because in the internet, it's internet telemetry, it's very uncontrolled. So there's a lot of weird stuff you see.
Hmm.
And not all of it is fraud. A lot of it is just misconfigurations or misdeployments or that sort of thing. So you have to, first of all, identify it. And that's often based on following a series of hunches. And then you need to connect it to some kind of money flow because accidents happen. Accidents often get either ignored or they get fixed away. But something that persists over time is there probably with some intent. The kind of things that we did look for would be you mentioned refer, and that's an interesting one. Refer is unreliable because the client side has like total control over what goes
Yeah,
into the refer.
set it to anything.
Right. And early on in the web, I think the refer was heavily used in analytics. And with the advent of ad exchanges and the complexity of how ads are even delivered, makes the refer less useful. And now that privacy is emerging as an increasing concern, refer is even less used. And there's now even browser policies that block use of the refer. And as a result, attribution has for a few years now, I think, largely moved away from refer.
Interesting. Could you get into where ad attribution does come from then? What are the new sources?
That's a good question. A major technology for attribution is this API enabled iframe called the safe frame. This is an industry standard type of technology that you can use to display your ad inside it. It's a sandboxed environment. The SafeFrame environment is available on all the major platforms. It's integrated with Google's DoubleClick for Publishers platform, for example. And the way that attribution through the SafeFrame works is that information is passed into the SafeFrame API. And when the API renders in the browser and makes the appropriate calls to get the creative that displays inside of the SafeFrame, part of that communication line includes what the owner of the SafeFrame is telling the creative the placement actually is. However, the creative has to trust the information coming to it from its enclosing environment, if that makes sense.
Well, in a lot of descriptions of ad tech, most people describe three entities involved. You have the user, which would be me visiting a website, the publisher, which is like Reddit or someplace I've gone to who has an ad space available, and then the advertiser who is paying to get their ad shown. Is one of these three the criminal? And if not, who's doing the dirty deed here?
There's a big piece of this that's not on that list. The simplest view of the commercial web is you do have the publishers, advertisers, and the users. And the users are the ones who interact with the publishers and generate the value of the publishers, which then sell to the brands, the advertisers. The way that publishers and brands connect is not directly, usually. It does happen on occasion, but that doesn't scale. We've got in the world there are thousands of publishers out there, and there are millions of brands. And it's not like you have
Mhm.
1,000 publishers trying to connect with thousands of brands. That doesn't scale. So instead, to solve this problem, we have these ad exchanges that consolidate the handling of that relationship. The bad actors here are none of the above. They're usually not the publishers, or they're usually not acting in the publishing role. They are more closer aligned with that ad exchange space. So there's less direct accountability, there's less traceability at the network level. There's a lot more anonymity. You know who you're dealing with through account numbers rather than through like personal exchanges. And that's really where the money is directly accessible. You can't go to a brand and just say, hey, give me X amount of dollars and I'll just deal with your campaign. That's not how that works. The relationship has to be a little bit more transactional in order to make this work. And that really happens at the exchanges.
So, do you think the exchanges need to make changes to block these sorts of types of fraud?
Let me be clear. I don't have a solution to fraud in the industry, and I'm not going to opine about how fraud should be handled by any one entity. And I also make it clear that I'm speaking about our paper, and I'm no longer affiliated with any participant in the ad tech industry. So my opinions are my own.
The best type of opinion.
I think ad fraud is challenging for reasons of scale, for technology, for tooling, for culture. There are people who understand the business side well, but they don't understand the technical side well. There are people who understand the technical side well, and they don't understand the business side well. The tooling is, I think, an outgrowth of sort of the early years of the web, where really validating where ads were being displayed was not really thought about when like HTTP or HTTPS were being designed. It was, let's just get this really cool technology into as many hands as possible, and then people sort of shoehorned making money on top of that after the fact. I think when you look at where we are today after, we'll call it 25 plus years of the web, commercial web, it's largely been a success. The system basically works. And ad fraud is definitely one of those things that is a problem that needs to be addressed. But it doesn't lend itself to an automated solution because the space, as we already talked about, is quite broad. It's a very broad term. And the risk is always on false positives, which means that if you are going to declare a portion of somebody's traffic to be fraudulent, that at the end of the day means somebody's not going to get paid. And unless you've got, a very solid case that can be understood by anybody who looks at it, somebody who's non-technical, somebody who's technical, that sort of process isn't going to fly. And the challenge of designing a scalable, automated process is largely a function of how complex the use cases of the web are.
Hmm.
Like if you think of Twitch, for example, people will go to Twitch and the user's behavior on Twitch is much different from what the user's behavior on like a news site like CNN or
Hmm.
New York Times is. And like on local news sites, I recall galleries were a big thing. And like the user behavior that you see on galleries is much different from the user behavior that you'd see on like Reddit, for example. A scalable approach to detecting fraud has to account for all of these types of user behaviors, all of the demographics that go into it. And that, by proxy, you can talk about device types, IP types, whether it's IPv4, IPv6, geographic isolation, geographic hotspots. I mean, all of these things you can use as signals for fraud, but they're not all going to scale equally well across all types of sites and use cases.
Could you talk a little bit more about the data you had access to in this paper?
Comscore was in a really interesting space. They act as this third party, trusted third party in measuring commercial web traffic, both for publishers and advertisers and the mobile web. They have a few different perspectives on the data. You can measure, so let's take a step back. There's a lot of ways you can measure internet traffic. You can measure it at like the switch level, so you're getting kind of raw packet level stuff. You can have devices in homes that are like home routers and they transmit HTTP traffic or secure traffic back to some server calling home. You can have JavaScript tags deployed on either web pages or alongside web ad creatives. And when that JavaScript renders alongside the content, it'll issue a request for a pixel or it'll send telemetry back to some server. So there's a lot of different ways that you can measure web traffic. Comscore was measuring traffic using tags on publisher sites. It had insight into campaigns by deploying telemetry alongside creatives. It has also this network of what they call the panel. Panelists are, if you're familiar with how television is measured back in the day, there were people who opted in to report how they view, their evening TV, and television has been measured in this way, since the 50s. Comscore does the same sort of thing, but for digital media. They invite people to report on their web browsing behavior, and they have this device then in the home that reports back sort of a clear view of HTTP. And they're not alone in doing this. There are a few players who also do this sort of thing, and they're usually disclosed. The other parties are disclosing this activity in their terms of service, which is why it's important to read terms of service when you sign up to this kind of measurement. Comscore has this sort of information. It was processing, I'll say, large volumes daily of this from a few different perspectives. And we use these to sort of reconcile the different viewpoints that we would have. So when, some laundry detergent is running an ad, we would get the campaign of the laundry detergent and we would see that telemetry come in. We could then go look at the panelist data that was coming in and see that validate that we were seeing, such and such a fraction of campaign data. And then we could see that, these are being attributed to, such and such a publisher. And then we could go look at the publisher tag data and sort of try to reconcile these three different data streams into each other. So those were our primary sources, and the diagnosis of actual fraud was facilitated most by the panel data because it gave us very granular detail into all aspects of every HTTP request, including the IP address that domain names were resolving to from the client side. And we leveraged this in one of the detection schemes that we did manage to get some traction on.
So that's an interesting subtlety. I think I'm going to a domain name, but behind the scenes, there's DNS telling me actually go to this number. How do I exploit that?
Well, in a word, malware.
Hmm.
End users, especially on certain platforms, are often clicking through, go ahead and install, I accept, make it go. As they're doing this, behind the scenes, as you click accept, typing in your password, allowing things to get running, to play whatever game or whatever it is you're trying to do.
Hmm.
Behind the scenes, you don't really know what's going on, and you never actually do. And it's very hard to get insight. Even when you are extremely technical, you often don't know, or you're just hurried because we're all people. What can go on behind the scenes is software that's malicious can overwrite critical files, like on the Unixy type sites, it's etc hosts file can get updated. And anybody who has access to some of that critical file structure can then run rampant over your system. And usually they don't want to cause immediate destruction and raise all sorts of alarms. Usually they want to control some aspect that will get them money. Usually that means they want your system functioning in a way that allows you to use it for the next, X weeks and not really notice anything going on. So if they do update your etc hosts file to send you from, you think you're going to some trusted great domain and they, replace the IP address with that domain with something that they control, um, what that will do is your initial request will go to the malicious uncontrolled domain, and they will do whatever nefarious activities they want to do by delivering some payload from that. And then it's very possible that they could then forward you along to the domain that you thought you were going to. So from your end user's perspective, you may not
Hmm.
even know that anything bad was going on. And the malware gets to accomplish whatever it set out to do. And we saw a lot of this sort of thing going on when we were looking at these sort of traces. It's quite interesting because you can see it kind of laid bare exactly what's going on there.
When you've got that data, it sounds like from the panel then, and you have sort of all the raw request data, you can see this in more plain sight. Do you have to have that access, or could maybe some ad network detect this by some technique?
No, I think no. The reason is that getting back to web audience measurement, there's two kinds of measurement. There's technical measurement. So this is like network layer infrastructure stuff. That's complicated already, but usually when there are problems, you can diagnose it. There's a network outage, some misconfiguration. You can dive in, an engineer can dive into the details and sort of sort that out. Audience measurement or like web attribution measurement, the internet really isn't instrumented to do this. So we've put in all sorts of proxy methods that allow us to do this. What that means is that from the advertiser's perspective, when they want to measure how a campaign is doing or where a campaign is deployed, their visibility into what is happening to their creatives in the wild is extremely limited. From their viewpoint, they're seeing things from within iframes usually. And that means that from within the iframe, the code in there can look to the boundaries of the iframe. They have to sort of trust whatever the iframe is telling them. And they can like send little requests to other servers. But they can't do a whole lot more than that. They can inspect the requests for IP addresses. Analysts can go back and look for anomalies that they think are malicious, but there's not too many features in that data stream that allow you to go back and say, well, this is clearly malware. That's very challenging from the perspective, unless you have kind of a detailed client side perspective like antivirus software providers can provide, or people like the panelists can provide. Or that.
Well, those IP addresses that you then uncovered, those are certainly owned by the malicious actor. Can those be a clue in maybe finding the source and stamping this out?
You would hope so. However, as with all things in this space, it seems to be far more challenging than the quick answer you might hope for. And the reason is cloud service providers are ubiquitous now. Very often, it's easiest to just spin up an ephemeral IP address, use it for a few days, and then spin it down. With the scale that those services operate at, it's very hard to set up again a scalable process that could prevent this kind of activity from occurring on those platforms because the types of signals that they emit are pretty innocuous. You're setting up a web server, you're engaging with client-side requests and maybe some server-side requests, and it's not especially bad looking. And from the cloud service provider's perspective, it's not causing any direct harm to their services or anybody who they're actually interacting with. It's a hard thing to identify from
Yeah.
from above.
Is this, a dirty secret of ad tech that we can come up with a solution for and fix, or do you think we have a more systemic problem?
It's not a secret. There is nobody who's worked in ad tech for any length of time who can claim either that they didn't know about fraud, they didn't know it was a problem, they didn't know somebody who got a clawback because there was fraud on their system. Everybody knows it's out there. And as far as systemic problems, I don't think it's a systemic problem or it's that people don't care. I think the fundamental problem is a technological and tooling one. There's no technology, at least that I'm aware of, that is practical and could solve most of the types of fraud that we know about. If you think about the browser security model as it's accepted right now, its objective is to allow for people to browse the web more or less safely. And you can't have kind of the bad old days when we had like random pop-ups and unrestricted server-side control of the browser like that. Back in the early days of the web, it was very much the Wild West. And the browser security model is an outgrowth of that. We've got iframes are pretty well sandboxed. Code that's running inside of iframes can't really escape very easily unless you exploit something pretty malicious and clever. The ad industry has to work within that framework. They just have to accept that their ads are by and large going to be deployed in kind of sandboxed environments. And as long as you've got that, unless you're willing to really push hard and ask all the browsers to get on board with allowing information to start flowing across that boundary in some client side way, I think it would be, I mean, there are solutions that you could come up with. I mean, you could think of setting up some global trusted third party where publishers and advertisers would try to reconcile requests dynamically real time. I don't know how much buy-in there would be there because it would introduce friction into the system in places that doesn't really lend itself to friction. I think there would be kind of a mad scramble for who would control that kind of global view. And I mean, this is just sort of me trying to prescribe a solution on the industry. Who
Yeah.
I don't know how wise that is, but yeah, I don't see a clear solution on the horizon.
Well, I believe your research was really what kind of debuted this idea of placement laundering to the world, or at least was sort of the first proven case and established it in the literature. Have you seen any industry response or even other researchers that have taken up the helm and shown an interest in this?
I just saw yesterday on Hacker News there was some discussion on the front page about some incident where I wouldn't call it placement laundering, but it was definitely a malicious ad on one of the major platforms that was had the image of the image manipulation program, the GIMP.org, but it was the target URL was a malicious URL. In reading the comments on that story, it was interesting because it seemed that there were some people who were maybe a little surprised or thought this was novel. And my reaction was that this is not particularly novel nor surprising. That says to me that there's definitely awareness within the industry, but outside of the industry, I think there's still some surprise at it. Over the years, and even when I was working closely in the industry, um, we would see press releases, events that were ad fraud, and they would get some play for a few weeks. There would be fire drills to try and remove what was identified in the press for this one incident from campaign telemetry. And that's sort of the pattern that has become the norm, where if something is highlighted and there's a lot of attention drawn to an event, that squeaky wheel gets fixed, and then things settle down until the next one a few months later. That suggests to me that things are in sort of an uncomfortable equilibrium.
So I think anyone who does digital advertising has to have some mental tool for reconciling fraud. Like just assume, everything's been watered down by 10% or whatever it is, and just kind of make some crude adjustment or maybe an informed adjustment. So I would want to make some sort of adjustment to assume some of my ad traffic was from placement laundering. I don't know if I can ask you to estimate that because it might be an impossible task given the involvement of malware and you don't have access to every end user system. But is there any way we can ballpark what percentage of traffic, or at least maybe the magnitude of the size of the problem is?
Again, that's a good question, and I'll preface this by saying I have not had direct access to data that would inform me about my answer in some time now. So it's based on a snapshot from some time ago.
Hmm.
A deflation factor is useful, and I I guess if I were doing it without really knowing, I would say 10% is probably a fine number, but that is not a terribly informed idea. A better mental model is to think about this in terms of what I recall seeing, and it was incidents of of fraud, whether it was placement laundering or other types of malware attacks or whatever, these were not stationary processes over time. Every incident of fraud is an individual or a small group of individuals who have deployed an attack. Unless there's a ramp up that they've engineered in, it's a step change that has a finite duration, and their goal is to sort of live under the radar of detection mechanisms. So the nature of fraud was, I don't want to call it spiky, but it was a series of discrete events that would impact kind of narrowly focused slices of traffic. As a result of that nature, it's hard to come up with kind of a holistic like 10% number. It's hard to just
Hmm.
say, well, because it spiked between June and July of last summer to 50% on this company's campaign, that I'm now happy to say it's 10% globally. Like it just doesn't work that way. Usually it's a specific campaign, it's a specific type of malware that's active for a few weeks. It's a kind of a very narrowly focused type of activity that we would see.
I know this was a project that kind of got completed. Can you speak a little bit, even if it's totally unrelated, about what you've been working on since?
I left ComScore and I joined another digital audience company based in Los Angeles. And I worked remotely for about a year with that company. And then I left to join an insurance company doing machine learning and research in insurance. Most recently, I left insurance to join the financial tech sector, where I currently work.
And how have the methods of data science and machine learning transferred across industries for you?
With a background in math, you can bring your skill set there to pretty much any kind of data science or analytics activity. The common skill that I've used across industries is identifying value and structure in data, raw data assets. That's a universally valued skill. It applies in all areas. I think both in data science and analytics, having deep understanding of how the data is collected, how the data is used, and why the questions being asked of your data are being asked are critical. And those are skills you can use no matter where you're working.
And is there anywhere your listeners can follow you online?
I have a LinkedIn profile, but that's the extent of my public persona.
Yeah, we'll put a link in the show notes for listeners to connect. Jeff, thank you so much for taking the time to come on and share your work.
Thank you for having me. It was a pleasure.
Well, that concludes this installment of Data Skeptic Ad Tech. Here's a quick preview of next week.
But now these platforms are providing opportunities for targeted audience. Like we can provide specific attributes like people who live in this particular area, who have this kind of interest, who can belong to these racial or gender groups. They are the ones who I want to target.
That's next time on Data Skeptic Ad Tech.